This is going to be my last video on the subject, but I wanted to summarize a lot of what was discussed on stream last week with the Bambu H2D. I know a lot of people are really excited about the new printer, and I'm not trying to rain on your parade. I do, however, want to take a more objective look at what it offers and give a proper critique as much as I can. Many people have been looking forward to a larger X1C, and the H2D is a little bit bigger, but not by that much. And this is my first frustration with the design, because while it advertises a 350 by 320 by 325 millimeter build volume, that's not really true. It feels very deceptive, in fact, to put that on there, because in 90% of cases, you will not use that full volume. If you are using a single nozzle, you lose access to a 25 millimeter band on one side. And if you're using two nozzles, you lose another 25 millimeter band on the other side. This is because the two nozzles that are present require 25 millimeters for side-to-side clearance. In very select cases, you can actually take advantage of the full build volume, but if you've ever run into the frustration of the X1C's exclusion zone, be prepared for a lot more of that in the future. So why did Bambu go with a dual extruder? It does allow you to have entirely different filaments queued up and ready to go. You can mix and match filaments that are typically bad for each other, like PLA and PETG for breakaway supports. You can have one nozzle running a soft filament like TPU, while the other runs a rigid filament like PETG. And this does open up a lot of functionality in your prints by leveraging different filament properties on the fly. A dual extruder isn't the only way to achieve this, however. The Prusa XL is also capable of this by using its tool changer mechanism. So what's the advantage of a dual extruder, and why did Bambu choose to go this route instead of a tool changer? Well, if you have a dual extruder, you have a lot more control over the repeatability and positioning of the extrusion nozzles. Since they are mechanically locked together on the same carriage, you can eliminate any kind of offset that may occur when the tool heads would need to switch. This issue does crop up on tool changer designs and manifests as artifacting from the simple fact that the swapped tool heads aren't perfectly aligned with each other. If one tool head happens to be 0.2 millimeters offset in one direction from the other in the same holder, then that will manifest as a whole host of 0.2 millimeter errors in your project. But if the two heads are locked together, then you can ensure you know exactly what offset to use, and these errors can be eliminated. That's the main benefit of dual extrusion over tool changing. On the flip side, tool changing is not really a new technology at all. It's just not that common yet in 3D printing. In the world of CNC machining though, tool changing is a well-considered and solved problem. The most precise things you might own are likely made with CNC processing, and there's a very good chance that the machine had built-in tool changing. So what's the difference? Well, for this, I want to turn to one of my favorite YouTubers, Marius Hornberger. When he made his DIY CNC router, he built an automatic tool changer, and it includes a common feature of other CNC machines with the same capabilities: tool measurement. Using this sensor in the corner of the workspace, the machine will measure each tool whenever needed to ensure that it knows exactly where the action is happening. With that, and the tight tolerances of a tapered collet style interface, the tools are reliably loaded each time and their exact dimensions can be determined. This is where Prusa's implementation leaves a bit to be desired. They use a mechanical pin and calibration sequence to determine the size and position of each nozzle. This does work to a large extent, but the still present quality issues reported by users suggest that it's not quite enough. It is also biased toward whatever hardware Prusa designed it to be used for, and makes modification for that hardware more difficult to calibrate for. What has Bambu done instead? Well, X and Y offsets are taken care of by virtue of the nozzles sharing a rigid carriage. It also employs an eddy current sensor mounted to the bed as a way to accurately determine the relative Z offset of each nozzle. If we assume that the frame of the H2D is perfectly square, this should be enough to account for deviation in all three axes. But as you may know, in an investigation, assumptions can kill. So Bambu employs another trick with their new optical vision calibration. To understand why this is needed, let's consider a dual extruder printer with a 1-degree bed tilt in the x-axis between the gantry and the bed. Using the information from the eddy current sensor, we can get the movable nozzle to an exact Z height from the bed. For the purpose of illustration, we'll have this be the same height as the other nozzle, but realistically, you would use a different height to account for nozzle collisions. Because of the 1 degree tilt, when the eddy current sensor detects the correct Z height, the nozzle actually has an X offset of 0.007 millimeters or 7 microns. This is just one example though, and the values may be wildly different in real life. The gantry might have more or less than a 1 degree tilt, or it could be in both X and Y at the same time, but what this example does show is that there is another kind of error here to compensate for, and that is skew. Bambu has employed a new visual calibration system with this grid of mini QR codes. Each of these is a known size and shape designed to be recognized by the H2D's computer vision system. By comparing the size and shape against what the known values are, the H2D can adjust itself accordingly. The working combination of the eddy current sensor, routine visual calibration, in addition to the host of other sensors on board, all contribute to the H2D being able to accurately place the nozzle tip where it's supposed to be and account for any discrepancy between the two nozzles present in X, Y, and Z. But keep in mind that a tool changer can do these kinds of compensations just as easily. This device from Ember Prototypes showcases how optical calibration can easily be done to compensate for X and Y offsets on a tool changer setup. This could easily be retrofitted onto any existing Prusa XL to dramatically improve calibration quality and ease of use. Eddy current sensors aren't anything new either, and there are already a host of options for anyone that wants to implement one themselves. Very similar functionality could be had as is seen in the H2D. There are a number of distinct disadvantages to a dual extruder setup as well compared to a tool changer. First off, having a tool changer mechanism inherently means that the machine is more adaptable and can more readily accept future modification in tool sets. Bambu's H2D relies on a mechanical rail that must be manually operated to swap tools. Anything that will be added to future tool heads will need to be manually put in place by the user and will need to conform to the rail already existing on the H2D. This also means that the dual extruder head will always be present regardless of whether it is actually being used. This makes it an ever-present weight penalty when using the other functions of the machine. By contrast, a tool changer sheds the weight of the first tool when it swaps to the second tool. This keeps the carriage mass much lower and reduces belt and motor strain while enabling much faster accelerations. To understand this, let's take a look at the physics behind a simple stopping motion. Let's use 250 gram baseline for a print head. Using the claimed 20 meter per second squared acceleration of the X1C, we can do some simple math to determine the impact of added mass on the tool head. Force equals mass times acceleration. So simply inputting the values we have to start, we can determine that the motors and belts are exerting about 5 newtons of force. This gives us a budget of 5 newtons to play with. Being extremely generous and assuming the dual extruder head weighs only 1.5 times what the standard head would weigh, we have a total mass of 375 grams. Putting this into the same calculation takes our max acceleration down to 13.33 meters per second squared. This is a 33% penalty to the max acceleration. Most of the time while operating, a printer is not moving at its max speed. The X1C claims this to be 500 millimeters per second. But this is not really a useful stat. The acceleration is, however, because all that constant starting and stopping means that having a higher acceleration capacity is more impactful to print time overall. So when you consider the added tool head mass, this puts an effective kneecap on the print speed of the H2D. When you add even more mass onto the tool head with your laser, this gets even worse. Their claims of having the same accelerations on the H2D as are listed on the X1C have me very skeptical. The laws of physics are universal. The H2D still uses belts and still uses stepper motors for the X, Y, and Z movements. It's simply not possible to get the same acceleration from a heavier tool head. Now I want to talk about that laser. I want a laser. I just don't want a laser at the expense of 3D printing. Bambu has introduced a whole host of improvements to their chassis to enable this to perform well as a laser cutter and 3D printer. In spite of all that though, laser cutting is a very dirty process. You're setting things on fire in a controlled manner. That creates a lot of soot and debris. The problem is, this is now floating inside your build chamber. The ventilation of the H2D looks good, but there are so many nooks and crannies for dirt to get trapped that I will be very surprised if there aren't a lot of complaints coming down the pipeline. If you put all that aside, does it do laser cutting well? I don't think so. I think this falls squarely in the jack of all trades category. Everything that I've seen suggests that the software for laser cutting with your H2D is lagging behind the competition by a considerable margin. It's very simplistic and is missing a number of features that should be considered standard. But there's a more pernicious issue that I see with the H2D, and it's shown in this clip from CNC Kitchen. Did you catch it? It moved. It moved because there's no default work holding solution for the H2D. It probably won't be long before someone comes up with some simple clips to hold things in place, but it shouldn't be up to the customer to have to worry about things like that when they're spending this much money on a finished product. Bambu has attracted a certain clientele. They're not the typical tinkerer and maker. The consequence of Bambu's mass appeal is that their customers will tend to be less technically savvy than they perhaps need to be to use a laser safely. So it behooves Bambu to make darn sure the machine is safe. If someone were nervous about getting a laser, but now that Bambu is releasing one, feels like they can manage it, that's exactly the kind of person that is in danger. Secure work holding is very important for a laser cutter. Suppose that in this video, Stefan wasn't just cutting some popsicle sticks. What if it was something reflective? If the piece is allowed to move, that means that the laser is not as constrained as you might think. When using a laser cutter, you need to treat it like the enemy. It is only waiting for you to let up and make a mistake. Once you do, that mistake can result in blindness, severe injury, fire, and a whole lot of other problems. In a cruel twist of irony, the set and forget ease of use Bambu has with its products are part of what make me nervous for people using this newest fire starter. So to recap, the Bambu H2D is not for me. It sacrifices core competencies as a 3D printer to be a middling performer in other categories. It doesn't reach the 350mm3 build volume I wanted. It doesn't even reach its own advertised build volume either. The laser still leaves me with a lot of concern, and I'd be very cautious to use this thing in its current state. I've mentioned in my other videos how I don't think Bambu has actually addressed security at all with their latest policy and firmware updates, and that hasn't changed. That only adds to my concern with this new laser attachment. However, there are still a lot of things to be excited about with the H2D, even if I won't be getting one myself. The sensor implementations we talked about for calibration all show sensible approaches to how the next generation of 3D printers might operate. This to me is the most exciting part. I'm looking forward to seeing what the competition brings out. Better calibration, smarter technology, and better tool changers are all right around the corner.